Hi there folks, Root Beer here, and I hope you're all doing well. We're going to continue our look at the 2010 Fermat paper, which is the grade 11 multiple choice contest, with question number 14 here. So, 4 friends went fishing one day and caught a total of 11 fish. Good for them. Each person caught at least 1 fish. All of the following statements could be true. Which one of the statements must be true? Oh, this is interesting. Okay, you couldn't really get this on a written contest. So I think it's nice and neat that you get these sorts of questions with the multiple choice format. So, at least one person caught exactly 1 fish. At least one person caught exactly 3 fish. At least one person caught more than 3 fish. At least one person caught fewer than 3 fish. At least 2 people each caught more than 1 fish. Okay. So we've got 11 fish. Now, everyone catches at least 1 fish. Good. So that takes care of 4 of the fish. And I'm not exactly sure the best approach for this question. Certainly not necessarily the best approach for showing it in an online video. But I've got my people A, B, C, and D. And I know they each catch at least 1 fish. So we'll put a 1 tally for each of them. Okay. What I think is the best way to do this question is to go through each statement, A through E. Just go down the list or go up the list if you think one of the latter ones is going to, or bounce around if you think that some answers are more likely than others. I know some people who think B comes up more often than not, or things like that. But you just take each statement and maybe take the statements that catch your eye the most, like more than 3 fish. That's an interesting one. So, we just take each one in turn and say, well, can this be true? Can I find a way to make this true? Now, we know each of them could be true. Which one must be true? We're actually going to try and find ways to make these not true. So, for example, A, at least one person caught exactly 1 fish. Well, is there a way to do this where everyone catches at least 2 fish? Certainly, you could have, actually, I think, here's what I'm going to do. I'm going to make my chart of counterexamples. We'll have our people A, B, C, and D. And then here's A. And if I can find a way to make A not true, then it doesn't have to necessarily be true. It could be, but it doesn't have to be. And that's what must means. So can I find a way to make it so that not everyone that there is no one who gets 1 fish? Well, sure. If everyone gets at least 2, that's 8 fish already spoken for. There's 11, so just give, 5 of them to person D. Okay? No one has 1 fish there. But statement A says at least one person caught exactly 1 fish. Well, that's not true. So A is out. And we'll just go down the list because I don't have the answer memorized and I don't know where it is. It could be E, in which case this video will be long. It could be B, in which case, well, I'll still probably go through all of them and show why only one of them must be true. So B, at least one person caught exactly 3 fish. Exactly 3. So as long as I can fill in these numbers and they add up to 11 and there isn't a 3 among them, B isn't necessarily true. So what could we have? Well, 2, 2, and 5 would do the trick just fine. Doesn't have to be that one, but I just realized while I was talking that the situation for A also works for B. No one caught exactly 3 fish there. Okay. C, at least one person caught more than 3 fish. Now this seems like, certainly the previous case of 2, 2, 2, and the last person gets 5 would work here, but we got to try and break the system. Is there a way, they specifically say more, caught more than 3 fish. So I could have, well, let's start giving people 3 fish, actually. Use up our fish as quickly as possible. 3, 3, 3, that's 9 fish, and then 2 left over. No one here has more than 3 fish. Some of them caught exactly 3, but I'm not seeing a 4 or a 5 or a 6, so C isn't necessarily true. Again, there are ways to make C true, but C doesn't have to be true. So D, at least one person caught fewer than 3 fish. Fewer than 3 fish. So I need to see a 1 or a 2 or a 0. Except I'll never see a 0 because everyone caught at least one fish. So is there a way to fill this in so that I don't see any 1s or 2s? Well, I got to start with 3s. But as soon as people get at least 3 3s, D is stuck with 2, just like the previous case, but that's less than 3. So did I do something wrong? Well, no, I've got to start at least with 3. Now you might say, well, why not take a look with 4? Well, 4 is using up more fish. And so by the time we get to the end with D, how many fish did D get? Well, it's even less. And this is why our answer of D is the one that is necessarily true. This one must be true, simply because there's not enough fish to go around. Just inspired by our last question, if we got 11 fish and 4 people, that's an average of, 2.75 fish caught. Okay. When you're talking about an average, either everyone got the same number, or at least one person got above this number, and at least one person got below this number, and that would be in the 2, 1, or 0 fish range. And this is why D has to be true. But let's also show why that there is at least one way that E might not be true. At least 2 people caught more than 1 fish. Well, we could have 1, 1, 1, and D manages to catch 8 because they're a great fisher. So that's a way that E would fail. One person caught more than 1 fish, but not 2, not at least 2. So our answer here is going to be D. And I like a good little logic question every now and again. There wasn't a whole lot of calculation here, but it's a nice question. You don't have to go through it as slow as I did. You don't have to make a chart. You can just sit there and sort of logic it out if you want. But D is going to be our answer, and that wraps up question 14. In the next video, of course, question 15. I'll see you there.